Bonsuelo mathletes, okay, you got to stick with me on this one. If at any point you don't get something, you just got to stop, because then the next thing's not going to make any sense. Okay, remember back when I graphed quadratic functions a couple of videos ago, I said you can have two different forms for the same function, okay? Well, I'm going to talk about how to, and it's like I said, for a line. You can have standard form, slope-intercept form, or point slope, and you should know how to change from one to the other. Well, same thing here. There are two forms. You should know how to change from one to the other, okay? I'm not solving an equation. I'm just changing forms. The first thing I want to say, this is what a lot of people do, is you see this y here? Is they drop it. And once you do that, you will not understand anything you're doing, okay? Why? Because there's a huge difference between y equals and 0 equals. You remember? Don't write this down. 0 equals x squared minus 4. Y equals x squared minus 4. First one, you can only solve it. You can't graph it. The second one, you can graph it. Now, when I ask you to find intercepts, yes, you plug 0 in for the y, but after you plug the 0 in for the y, you're just finding the intercepts. Okay, and then for the x-intercept, you would plug 0 in for the y-intercept, you plug 0 in for x. But you have to, if you are not very careful about the difference between these two equations, you're not going to know whether you're in history class or math class in about 2 days, something like that. Okay, first one, let's do the easy one first. Changing vertex form into standard form, all you do is multiply, okay? Okay, so we square the x plus 3. You should know how to do that. It's x squared plus 6x plus 9. Distribute the 2. Okay, right away, you're dust. If you're doing what I'm doing here, you're dust. You didn't put the y equals, okay? And I didn't do it intentionally. A lot of times I make mistakes I have to go back and correct. Here I did it intentionally. I can't emphasize it enough. So that's 2x squared plus 12x plus 18 minus 7. Okay, then y equals 2x squared plus 12x plus 11. If you graph this and then you graph this, you'll get the exact same thing. Okay, that's the simple one. Now, here's the tough one. What we're going to do is we're going to do it by completing the square, okay? And if you drop the y on this, like I say, in a couple days, you don't even know what class you're going to be in. All right, now, I'm going to write a bunch of junk down. Don't write any of it down, okay? Just listen. And then eventually I'll tell you when to start writing again. Okay. Let's say I give you x plus 5 squared. Okay, that would be x squared plus what plus what? Stop the video, think about it for a second. What would it be? Okay, I'm assuming you've already thought about it. You should know that this is 10x and this is 25. Okay? All right, next one. What if I give you like x plus blank is x squared plus 14x plus blank. Okay? Fill in the blanks. Just look at it, see if you can figure out what it is. Turn off the video for a second. Okay, assume you've already thought about it. What would it be? This one would be 7. And this one would be 49. Now, how do we get that? Because notice this thing, if you look at the first one, is twice x plus 5, right? It's just x plus 5 times x plus 5. And this is the 5 squared. So on the second one, I took the 14 and divided by 2, because if the middle one is twice, if the 10 is twice the 5, then the 14 is twice whatever was in this blank, right? So to go from the 14 to the 7, you divide by 2. If you don't get that, stop and listen to it again. But I'll put another one in a second. I'll put another one up in a second. And then to get this last one, you would square that. So here, to get what's in this first blank, I'm going to take that 14 and divide by 2 and get 7. Then the last blank is I would just square that. Okay? Now, I'll give you another one. Okay, if that leads to x squared plus, I don't know. Oh, let's make it 12x. Okay, what would be in the first blank? And don't just wait for me. Pause the video and think about it yourself. Okay, I assume you're back. Okay, it's going to be 6. Because that term right there is just going to be 6 plus 6. Okay, and then what would be in the last blank? Again, don't just wait for me. Do it yourself. Because if you're not going to understand this. Okay, but I'll assume you've already thought about it. That should be 36. Okay, now, last one. I don't want you to put anything in the set of parentheses. You can do anything in your head that you want. Okay? All I want you to do is tell me what goes in this blank. You're doing the same thing. I just don't want you to write down the thing in the parentheses. Okay, think about it. Okay, I assume you thought about it. You come back. This number should be 100. Why? Because I'm going to take this, cut it in half, and square it. Why? Because that's what I did in the first 3 examples. I just didn't write anything in this area here, right? Like in the second one, I took the 14 divided by 2, got the 7, then I squared it and got the 49. Third example, I took the 12 divided by 2 and got 6, then squared it and got the 36. I'm just not going to write it down. If you can do that, you can do, and you don't need to write this down, okay? Believe me, you'll have plenty to write down. But if you can do that, you can do the main thing you need to do here. You can't do the hardest thing there is to do. But if you can't do that, what I just did, the rest of it doesn't matter. You're not going to be able to do the hardest part. Okay. Well, if you go back and look at those examples that I just erased, what I did is I had like this part alone, and I was always asking you what number should go there. Okay? So what I want to do is get rid of that number and just get the x squared minus 6x kind of isolated. If you go back and look at those 4 examples I just erased, okay? And what I'm going to do is put the x squared plus 6x, minus 6x in parentheses by itself and get rid of the 1. So what do you have to have? You have to have no number there, and this number at the beginning must be 1. Okay? All right, now the question is this. What number do you put in that parentheses, at the end of that parentheses, to make the thing a perfect square? Well, what do? You take half of the 6 and square it. If you don't get that, go back and look at those first 3 examples, or 4 examples, that's all I did. So it's x minus 6x, and I'm going to put that at the end, plus 9. Okay? And now all I do is factor it. Okay? See, what does this form have? What does vertex form have that's distinct from standard form? It has this quantity squared That's what you're trying to get. That's why it's called completing the square, because what you're doing is you're taking something that's not a perfect square and making it into a perfect square. Okay? Is that it? Well, actually, yeah, that is it, although that's not the hard part. There's a hard part that's coming up. But I mean, that's the basic idea. If you can't do that, the rest of it's not going to make any sense to you. Okay? So you got to get that down first. All right? Okay, now let's take a look here. By the way, I want to point out something. I know this is going to sound stupid, but when I wrote this plus 9 here at the end, what did I add to that side of the equation that wasn't there before? And hopefully the answer is 9. Okay? I just want to make sure you understand that. Notice up here, there was no 9, and now in the next line, there is a 9. I added 9. Okay? All right, let's take a look at the next one. Okay, so try it yourself on number 1. Actually, you should, I've always saying, you should try these on your own first. And if you're not, I don't know, it's not really going to help you. To just keep watching me. Okay, so I assume you've already tried it on your own. So I'm going to, isolate the x squared minus 10x away from the 24. Okay, then I'm going to take that and I'm going to cut it in half and square it. Oh, gosh. You know what? Someone shoot me, please. I just totally blew it. Let's go back to something. I apologize. Well, that's okay. Maybe the fact that I blew it is fortuitous. Maybe it'll help you to be careful of something. Okay. I just made a huge mistake. Major, gigantic, bigger than that. Okay. I added 9, right? Okay. So what did I just add to that equation that wasn't there before? Again, if you take a look at step 2 right here, okay, there wasn't anything at the end of that parentheses, and now there's a 9. Well, I can't just add 9 because I'm changing what the equation would be. So if I'm going to add 9, what would I have to do at the same time to keep the equation the same thing? Subtract 9. Okay? And then what I have to do, and I'll talk more about that in a second, then what I have to do is add the 1 and the negative 9, and I get minus 8. I apologize. Okay? Now, let me point out something to you before I go any further. Don't write this part down. What are you always told? Whatever you do to one side of the equation, you have to do to the other side of the equation. And that's true, okay? I'm not changing that. But I'm going to look at it a little differently. Let's say you have y equals k plus m, okay? And then all of a sudden, for whatever reason you don't have to worry about, I decide to add a z on here, okay? Well, obviously, from this line to this line, I've now got an extra z, but that changes the equation. So what do I have to do at the same time? Well, most people would say, add a z to the other side of the equation, and that'd be true. But here's the thing. I want to keep this y alone. I don't want to do anything to this side of the equation. I always wanted to read y equals. Okay, so I'm not going to add a z. So what am I going to do? Well, if I add a z to this side, what would I have to do to the same side to keep everything the same? Subtract z. And don't write this down, okay? Because I just want to point out that's what I have to do so I'm not changing the equation. All right, notice the two equations are now the same. If I add this, the two equations are not the same. It's only if I add the z and subtract the z at the same time that I keep the equations the same. Why would I do that? I wouldn't do that on this thing I'm telling you not to write down. So that's why I'm going to get rid of it. But notice here, what I'm trying to do is make this thing in parentheses a perfect square. So I have to add 9, and I don't want to add 9 to the side with the y because I want to keep the side with the y as y, okay? So I'm going to subtract 9 at the same time, and then just combine. Okay, let's do another one. Okay, so again, I separate the 24 from the rest of it. I take the negative 10, cut it in half, and square it. That gives me 25. So now, what did I just add to that side of the equation that wasn't there before? There is now a 25 on the second line that was not. There's 25 more on the second line than were not on the first line. So to keep everything the same, I've got to subtract 25 at the same time. And now I'm going to factor it and combine those two things. Okay? So I'm telling you, if I graph f of x equals x squared minus 10x plus 24, and then I graph f of x equals x minus 5 quantity squared minus 1, I'd be graphing the exact same thing. They're just two forms of the same thing. Okay, let's take a look at number 2. Again, I'm not going to do anything to the side with the g of x, but I'm going to keep writing it. Okay, now notice I have two things I have to get rid of here, because I said this has to be 1 and this can't be there. Okay, so what I'm going to do is put down the 2 and the 3 outside the parentheses. Okay, so what would go inside the parentheses? Notice I'm taking a 2 out of both of those. So it would be x squared plus 8x. So essentially, I'm factoring out the 2. Okay, now what do? I take half of the 8 and square it. That gives me 16. Now, this is going to be the hard part. Okay, take a look. This is the equation as it is right now. But what I'm going to do is, now watch me. I know this is going to seem weird. I'm going to add 16 inside the parentheses. But that's not really correct. I didn't add 16. What I did is I wrote plus 16. Okay, and you go, well, what's the difference? It's this. Take a look at it. Okay, take a look at like number 1. When I wrote plus 25, I was putting 25 on that side of the equation that wasn't there before. So I had to subtract it at the same time outside the parentheses. Okay, when I wrote plus 16, what quantity am I putting on that side of the equation that wasn't there in the first line? So in other words, in this line up here, this first line, there's just this blank, and then there's this plus 16. Well, what was I actually, how many more what quantity is there that wasn't there before? Think about it. Take just a second to think about it, okay? And I'll tell you, it's not 16. I wrote a 16, but it's not 16. I mean, there is a 16 there. I'm not trying to say there isn't, but what quantity is now on that side of the equation because I wrote plus 16? And I'll just tell you, if you haven't figured it out, it's 32. Why? Because notice that 16 is in a parentheses, and that parentheses has a 2 in front of it. So by writing plus 16 inside the parentheses, there is now a 32 that wasn't up in this first line. There's a 2 times 16, so what do I need to do? I need to subtract 32. That's the hard part. The hard part is that, okay? It's remembering, like, what number, when I write something down there, what am I actually adding? Now, I wrote a 16, But what I'm actually adding to that side of the equation is 32. That's the hard part. I mean, and it's really hard. I'm not denying it. That's why if you have a question, just like stop it now and get me, okay? And then what do? We factor this. At that point, you just factor and then combine those two things, okay? Now, these next ones, I'm not going to change anything, but you're going to start dealing with fractions, okay? If you're not good with fractions, I don't know, this is going to be bad, okay? For instance, I'm going to write some stuff down. Don't write it down. Can you tell me if I divide 7 by 2, what do you get? Okay. If I divide 7 by 2, you get 7 halves. Fine. Let's say I take 3/5 and I divide by 2. Okay, you don't get this. You don't get 3/5 divided by 2. Okay, that is not what you get when you take 3/5 divided by 2. When you divide by 2, all you do is you stick a 2 in the denominator. You get 3/10. Okay, and if you don't get that, it's because you don't understand fractions. And you need to understand fractions. You need to understand basic grammar school math, okay? So when you divide by 2, you don't get 3/5 divided by 2. You get 3/10. Make sure you understand that. All right, now let's go ahead. Okay, again, what do we have to do? We have to separate the 5 and the -3. Okay. So we have x squared plus 16x. Okay, I'm going to take, and make sure you're writing this k of x equals in every step. Okay, so I'm going to take the 16, cut it in half and square it. So that's 16 divided by 2 is 8. Square it and you get 64. Now, what number did I actually add when I wrote plus 64? It's not 64. Yeah, I wrote a 64, but it's 5 times 64, okay? And what's that? 5 times 64 is 320. At least I hope so, okay? So what do we have to do? Subtract 320 at the same time. And at this point, I'm going to go through the rest of the problems pretty quickly because otherwise, people are going to go crazy. So factor it and then combine these. Okay. It's getting tougher. Okay, let's factor out the 3. So that would be, and move the negative 3, not 3. Move the -3 and the 2 outside. I need to leave myself a little more room there. Okay, so what would that be? X squared minus 6x, okay? So we'll take the -6, cut it in half and square it, and that'll give us 9. Now here's the hard part. Think about it. When I wrote plus 9 there, what did I actually add to that side of the equation? Okay, and what I actually added was -18. Okay, well, if I put -18 there, that wasn't there before, what do I have to do to keep everything the same? I have to add 18. Okay? Notice up here, like in number 3 here, when I put plus 64, since the 5 outside the parentheses was positive, I'm adding a 320. So to keep everything the same, I need to subtract a 320 at the same time. But here, the -3 outside the parentheses is negative. So when I wrote plus 9, whoa, am I really bad in math or what's the deal here? Yes, your teacher is bad in math. Okay, when I wrote -3, I subtracted 27, not 18. I apologize. Okay, I subtracted 27. So what do I have to do? I have to add 27 to keep everything the same. Okay? And now it's just same old, same old. So it's negative 3 times x minus 3 quantity squared plus 29. Okay, don't ever be scared to correct me, by the way. I don't mean like argue with me. I'm saying, like if I do something wrong and I don't correct myself, if I don't catch it, just tell me. I want you to tell me. I want you to be looking. Don't just assume that what I'm doing is right. What I'm doing is right as far as the method goes, but I make calculation errors just like everyone else. Okay? All right, let's take a look at number 5. Okay, so we have m of x. And again, give it your best shot on your own and then try it. Let's take out the 3. Okay, so what does that become? X squared plus 7/3 x. Okay, so now what do? You cut this in half, and that makes it 7/6. And then you square it. So you get 49/36. Okay. Now, this is going to be weird. Well, let me show you one thing real quickly, and then I'll say that. Can you tell me what's 5 times 7/40? Okay, if you told me it's 35/40, you don't really know how to deal with fractions. Okay? You should always cancel if possible. It's 7/8. All right? If you have a question on that, you got to come and see me. Just basic arithmetic. Okay. And then we have the minus 5 out here. Okay. So when I wrote plus 49/36, what did I actually add to that side of the equation? What quantity was not there before? And that's 3 times 49/36. So I have to subtract it. And what's 3 times 49/36? Well, it's not 147/36. It's 49/12. That's just all there is to it. 3 times 49/36. You cancel the 3 and the 36. It's 49/12. And you shouldn't be needing to write that. You should be able to do this in your head. This is grammar school. Just the simple 3 times 49/36 is grammar school arithmetic, okay? All right, and now we just do the same thing. And you're now asking yourself, how does he factor this? Well, it's really quite simple. You do the exact same thing I've told you all along. Is there greatest common factor? No. Is there a difference 2 squares are trinomial? Yes. So what do? Look at the first term, last term, check with the middle. Okay? What's the first term? X times x. And we know it's going to be a perfect square, so we don't need to write something times itself. Don't look at the 7/3. Okay? Don't look at the 7/3. It's going to mess you up. Okay, look at the last term. What times what gives you 49? Well, 7 times 7. What times what gives you 36? 6. It's that simple. I'm telling you, all your little boxes and all your little tricks, and it's just simple. First term, last term, check with the middle. Your little boxes and X's and all those don't really work. Okay? They work for Algebra 1 or 8th grade, but they don't work here. All right? Okay, and then we just get a common denominator and add these, so that'd be minus, someone correct me if I'm wrong, 109/12. Okay? First term, last term, check with the middle. All right, let's take a look at one more. Okay, so we have notice every line has y in it. Now, if you bring me a problem and you're not writing y on every line, I can't help you. Okay? Just the way it is. Okay, so we have r of x equals, let's separate out the 5. and the 7. So what would that leave us with? X squared minus 2/5 x. Okay. Now, let me show you something. I'm just going to write something down here. What's, I don't know, 3/7 divided by 2? Okay? If you take 3/7 and you divide by 2, you get, don't write this down, you get 3/14. Is that okay? You just stick a 2 in the denominator. Is that okay? Simple arithmetic. Okay. Can you tell me what's for 11ths divided by 2? It's not 4/22, 4/22. Because when you stick a 2 in the denominator, the 2 and the 4 cancel, and it gives you 2/11ths. It's just simple arithmetic. It's just simple fractions, okay? So here, when you stick 2, when you take this thing and stick 2 in the denominator, what do you get? You don't get 2/10. You get 1/5. Sorry, shouldn't be an F there. So you take the 2/5, you stick a 2 in the denominator, you get 1/5, and you square 1/5, and you get 1/25. Now, am I doing anything different than I did in these other problems up here? Nope. It's just a matter of whether you know how to deal with fractions or not. But if you want to know what I did here, you look at all these other problems. I'm doing the exact same thing. You just have to know basic arithmetic, okay? Now, I'm not saying you can't come and ask me questions, but I don't know. It's just, basic arithmetic. That's all. All right. Now, when I took my pen and I wrote 1 plus 1/25, what did I really add to that side of the equation? Okay. Like here, number 4. I added -3 times 9. Here, number 3, I added 5 times 64. So what did I add here that wasn't there before? 5 times 1/25, which is not 5/25. It's 1/5. So I subtract 1/5 to keep everything the same. Let me separate this a little bit here. And now what do? I factor. First term, last term, check with the middle. If you haven't been doing that all along, remember I told you a couple days ago, you're not going to know what you're doing if you're not practicing my methods on the simple problems. I just can't really help you if you're not willing to do what I'm telling you to do, okay? You need to do what I tell you to do when I tell you to do it. If you're waiting, you're never going to get caught up. That's all I can tell you. There's no magic to it. It's just doing what you're supposed to do when you're supposed to do it. So again, what's the first term? X squared, so it's x times x. What's the last term? 1/25. What times what gives you 1? Sorry, that shouldn't be a plus. That should have been a minus. Okay. What times what gives you 1? 1. What times what gives you 25? 5. And then, this would be 35 minus 1, which is 34/5. Okay? That's it. I'm not going to... Oh my! There is a bonus problem here. Okay, for those of you who are brave, follow the rest of it. If not, you don't really need to do this, but there's a reason why I'm going to do this bonus problem, because it will explain something I did before. How do you find the vertex? Like if I asked you to graph this, how did you find the vertex for this? Remember, the formula was -b/2a. And then you substituted that in. Okay, that's what we did a couple days ago. Well, I want to show you where that comes from. And you go, wow, Mr. Liebling, I'm so excited. I'm glad you're excited. Okay, what we're going to do is we're going to complete the square. So I'm going to factor out the a. I'm going to separate the a and the c. Okay, and I'm going to go through this pretty quickly because you don't have to know this. Actually, I have to admit, you don't have to listen to this at all if you really don't want to, but I like people to know why things work. I don't want to just say do something to do it. And I'll go through this quickly so if those of you who are interested can watch. Okay, so this would be x squared plus b over a x. Okay, we're going to take that middle term, cut it in half, and square it. So remember, the middle term, you're just taking the b over a. You're not taking b over ax, right? Like up here, I took, on number 5, I took 7/3, cut it in half, and squared it. I didn't take 7/3 x, just the 7/3. So I'm going to take the coefficient of the x, b over a, cut it in half, and square it. Maybe I should write a little bit more there, just for those of you who... So I'm going to take this, cut it in half, in other words, put a 2 in the bottom, and square it. So that would give me b squared over 4a squared. Whoa, this is exciting. Okay, and then remember the c's outside. Well, when I wrote b squared over 4a squared, what did I actually put on that side of the equation that wasn't up there in the previous one? Well, I wrote a b squared over 4a squared, but remember there's an a outside of the parentheses. So if I take a times that b squared over 4a squared, I get b squared over 4a. The a's cancel. So I have to subtract b squared over 4a. And again, why is it just 4a? Because I took this a and multiplied it by that, by, the whole fraction. So the a's, one of the a's canceled, and we ended up with b squared over 4a. Okay, so let's factor. So we have, what times what gives me x squared, x. What time, don't look at the middle term. What times what gives me b squared, b. What times what gives me 4, 2. What times what gives me a squared, a. And then I'm going to add these and get a common denominator. And if you don't remember how to get a common denominator for stuff like this, that's fine. It's not all that important right now. So it'd be 4, the common denominator is 4a. So you multiply top and bottom of this, the c, by 4a over 4a. So we get 4ac minus b squared. And it is not that big of a deal if you don't understand that. It is fine with me if you want to understand it to come in and ask me that question. I'd be happy to explain it. But I'm going to leave it there for now. Okay, what's the vertex for this thing, right? This is vertex form. Like here, on problem 1, what's the vertex? 5, comma, negative 1. Number 2, what's the vertex? Negative 4, comma, negative 29. Number 3, negative 8, comma, negative 8, comma, negative 323. It's just vertex form. Okay, it's just the shift, right? That's all the vertex is. Number 4, what's the vertex? 3, comma, 29. Number 5, what's the vertex? Negative 76, comma, negative 109 over 12ths. Number 6, that was number 5, sorry. Negative 76, comma, negative 109 twelfths. Number 6, what would the vertex be? 1/5, comma, 34 fifths. Well, what's the vertex for this one? It'd be negative b over 2a, comma, 4ac minus b squared over 4a. Okay? So when I gave you back a few days ago how to find the vertex of a parabola in standard form, ax squared plus bx plus c, I only gave you this part of it. Why? Well, I could have you memorize the 4ac minus b squared over 4a, but why bother? Why not just memorize the negative b over 2a and then take that number and plug it in? So you could actually have this whole thing memorized, and if you have an example of an equation, you just plug in a, b, and c to this whole formula. I don't know that it's really worth your time. But I just want, again, I don't like to tell people things and say just do it to do it. There's always a reason, and I like to explain the reason why. So where did I get that negative b over 2a where did it come from? From completing the square on f of x equals ax squared plus bx plus c. In other words, that's standard form. Woo! That was fun. That was great. I love it. I love it. I hope you love it too. Have a great day, everybody.